So changing this decimal to a fraction, I'm going to use what we call the rule of nines, you guys. Now on this one, it's showing the number 0.8 as the decimal. So I got a 0.8 right there, and I can divide it by a value. It's the rule of nines, so it's going to be nines. It's just how many nines do we got in the denominator. Well, it's two numbers that repeat, 0 and 8. So that means there's two nines right there. And yeah, I don't really want to write this as 0.8. I'd rather just write it as 8. And this fraction, if you were to type this into a calculator, would give you 0.08, but the 0.8 repeats forever and ever and ever. So that is one way to use the rule of nines to change this decimal to a fraction. So there's problems like this one where you can change into a fraction, but it's a little bit different. You can use the rule of nines, it's just it is different, okay? So here's what I would do if I was you guys. Is I'd say, you know what? I'm going to take this decimal, and remember that math is really just forcing things to be what you want it to be without changing values in between, all right? So we can apply our will to this decimal so it makes it more convenient to work with. So I'm going to say, you know what? This is now going to equal what I call n. And then what I'm going to do is I'm going to multiply the n and the 0.963 repeating by something that's going to allow the decimals to align, okay? So in other words, I would like this to have 6.3, 6.3, and then it just repeats forever, this 6.3 like this. Okay, and then I got a decimal place, but I need something here. And to do that, what I'm going to do is I'm going to move the decimal, what is that, 1, if I move that decimal, oh, looks like I got to move twice. Alright, so if I do that, then I get 96.363636. Now what I just did there is I multiplied this by 100. So I also kind of multiplied the n by 100 as well. So that means this equals now 100 of these n's. So 100 of the n's would be 96.363636 and so forth, okay? And then I'm going to compare it with the original n, which was 0. And I'll show some more of this stuff. 9636363, and yeah, that pattern continues on forever. But that was just one of the n's, right? Like this. Well, what I can do now is, again, I'm applying my will to this because I can. So I'm going to subtract these from each other, all right? So when that happens, of course, with subtraction, long subtraction like this, you'd start as far to the right as you can go, and these decimals, those points, kind of cancel each other out, and the 3's and the 6's and the 3's and the 6's and the 3's and the 6's and the 3's and 6's. So those are all just zeros. They zeroed out, which means we terminated them, all right? And now what I can do is subtract these, right? 3 minus 9, you're going to have to borrow from the 6. 13 minus 9 is 4, 5 minus 0 is 5, and 9 is just 9er. And now this equals 100 of the n's, right? We took 100 n's and subtracted the one n, with numerically speaking, but also with the n's. So that's going to give us 99 of those n's. See where that rule of nines comes from? The problem is, at this point, we got a decimal, so I could say, you know what, I'm going to solve for this. I'm going to divide both sides by old 99er like this. But the problem is that now this equals just one n. And remember what n equals? It was right here too. So n as a decimal is this, but as a fraction, it's showing right here. It's just the fraction as a decimal, which we can't have. So I've got to change that decimal into a not decimal, right? And I would do that by moving the decimal one space to the right, so I've got to do it in the denominator as well. And I need more space for this one. But then it becomes 954 over 990. Remember, that's n. Remember what n is? N is this decimal. So now we're showing that the decimal as a fraction is this garbage. This one says to change to a fraction. On this one, though, so you can use the rule of nines as long as the repeating decimal starts in the tenths, which is the first decimal place, okay? So I would actually start this one as a mixed number, right? It's 5 and then some number of, some fraction, right? And we got 0.5. I'm just going to write it as 5. That's my numerator. And then the number of 9s in the denominator is determined by how many numbers are repeating. There's 2 of them, so it's 2 9s right here like this. Okay. Now that's the mixed number. It says that it wants the fraction, so I'm going to write it as an improper fraction, right? So I'll use cycle method to change this into an improper fraction in 99ths. So yeah, 5 times 99, I'll do it by hand right here. And the 5 and a 4, 45, 49er, 495, and then plus the 5 numerator gives us 599ths. Nailed it. Well, again, on this one we see that the numbers begin to repeat at the tenths place value, which means I can simply take this number, 123, and divide it by, with the rule of 9s, how many numbers are repeating? 3, so 3 9ers. Now just be careful, some of you guys did this correct on the homework, it's just, forgot to simplify this, okay? And I can see from my rule of knowing that numbers are divisible by 3 that the numerator is divisible by 3. So I can divide this by 3 and the denominator by 3 to simplify it, which then would give me 41 333rds. Well, what about this stinking ugly piece of garbage? So I can't use the rule of 9s on this one because the decimal doesn't start to repeat until the thousandths place value. However, it's just one number that repeats, so this one's not going to be too bad. What I'm going to do in order for the numbers to match is, again, I'm going to say, well, this is equal to n, right? So I know n, this number that I've said, or this letter I says represents this number. It's good. But I want not just n, I'm going to, I'm going to make a few of these n's right here. So I'm going to multiply by 100 again. I think I could get away with 10 probably on this. Let's try 10 instead. I take that back. Let's try 10. Alright, so we're going to multiply it by 10, which really just moves the decimal one place value to the right. So then it becomes 783.26, and then these 6's just repeat forever and ever and ever. Now I took that and I multiplied it by 10, which means it's the same thing as saying I got 10 of these n's. Well, what was just a regular n? A regular 1n was 78.32, and then a bunch of 6's right there. And again, same property or same principle here. We're going to subtract these from each other so that we zero out all of the repeating parts of this. And when we do, we'll end up with just 9 of those n's. And 6 minus 2 is old 4. 2, we're going to have to borrow from this one right here. And this one right here. 12 minus 3 is 9er. 12 minus 8 is 4. 7 minus 7 is 0. And then we got the 7, right? So this now, it becomes solvable for us to change this into fraction by simply, what color am I looking for right now? There we go, this is a good one. Divide both sides by 9, and that tells us what n is. N equals this as a decimal, but this is going to give us the fraction. And yes, I do not want decimals in my fraction. So I'm going to move this decimal 2 times to the right, and this one I'm going to move 2 times to the right, which makes this 70,494 all over 990. And that may make you feel really good inside. You know what I'm saying? Like, hey, that was a lot of work. Feels good. But it's not simplified. Yeah, let me change that. Sometimes when I get going on these, I tend to make mistakes like that. Yes, it was 900. So, next thing I'm going to do is simplify this real quick. Yeah, I see both these are divisible by 2, by the way. So that give me 35, 247, all over 450. And let me see if this top number is divisible by 3. So 3, 8, 10, 17, 21. It's divisible by 3. Oh, dang it. Well, let's divide that by 3. Both of them by 3. So that'd be 1, 1, 4, 1. Oh, maybe it's not. Did I do? All right, I see the mistake there. It's a 22, so that'd be 7. 14 is a 4. 27 is a little 9er. There we go. And then 1, and then 15 is a 5. 0. Okay. Well, is this divisible by 3? So 1 plus 1 is 2, plus 7 is 9, plus... Nope, that's not divisible by 3. So it looks like this is the final fraction that I get out of this. And it's so pretty.